We'll be going over how to create double line graphs using tables. Let's look at the first question. Curiosity and Opportunity are rovers on Mars. The table below shows the number of meters traveled by Curiosity and Opportunity each month. Use the data in the table to complete the double line graph. Let's look at what is already graphed. We have the data for Curiosity already graphed on the line graph. Let's double check and make sure all the data is correct. First, let's look at the table. Here we have the data for Curiosity. Let's confirm each data point. In January, Curiosity traveled 100 meters. If we hover over the point here, we see that January has 100. That has been graphed correctly. In February, Curiosity traveled 90 meters. If we hover over, we see that is also graphed correctly. In March, Curiosity traveled 70 meters. If we hover over that data point for March, we see 70 meters. For April, Curiosity traveled 30 meters. That is also correct. And lastly, for May, we see Curiosity traveled 60. Now let's take a look at Opportunity. Opportunity has not been graphed yet, so we need to make all the points on the data graph. Let's start with January. In January, Opportunity traveled 40 meters. The meters are on the y-axis. When we go to January, we want to plot a point at 40 meters on the y-axis. So we travel up until we have reached 40 meters on the y-axis, and we place a data point. In February, Opportunity traveled 60 meters. We will travel up now for February, up the graph until we hit 60 meters on the y-axis, and we will plot a point. For March, Curiosity traveled 100 meters. We'll follow the same steps, go to March on the x-axis, and go up until we reach 100 on the y-axis. In April, Opportunity traveled 60 meters. We'll travel up now the y-axis until we reach 60 and plot a point. And the last point is May, 30 meters. We go to May and up 30 meters to the y-axis. We have now graphed both of the lines on the graph. Let's answer the question. Let's look at this next question. Samantha and Elizabeth both sell computers at the Best Computer Store. The table below shows the number of sales that each of them make during different months. Use the data in the table to complete the double line graph. This is very similar to the last problem. We have a chart of data over here that includes two columns, and then we also have a graph over here that has one set of data already graphed. The first set of data is for Samantha. The second set of data is for Elizabeth. Let's go ahead and graph Elizabeth's data. Starting with January on the x-axis, Elizabeth sold 70 computers at the Best Computer Store. Those values are on the y-axis. Let's go to January on the x-axis and travel up the y-axis until we reach 70 and plot a point. Let's look at February. For February, Elizabeth also sold 70 computers. Let's go to February on the x-axis and travel up until we reach 70 on the y-axis and plot another point. Now for March, Elizabeth sold 80 computers. Let's go to March on the x-axis and travel up to 80 and plot a point. For April, Elizabeth sold 40 computers. Let's go to April on the x-axis, travel up until we reach 40 on the y-axis. And our last and final point for Elizabeth is for May, where she sold 70 computers. So let's go back up to 70 and plot another point. Now we have plotted all the data points for Elizabeth and Samantha, and we can answer this question. Question number 3. Both Marstown and Bakersville are building new football stadiums. The table below shows the number of workers during various months for both cities. Use the data in the table to complete the double line graph. Similar to our last two problems, we have one plotted already. That would be for Marstown. Then we have a second set of data for Bakersville. For Bakersville, we want to plot all of the points on the graph. So let's start With our first point, January. Bakersville had 70 construction workers at different stadiums. Let's go to January on the x-axis and travel up until we reach 70 on the y-axis, and we'll plot a point. Let's look at our next point, February. In February, Bakersville had 60 construction workers at different stadiums. Let's go to February, travel up the y-axis, and plot a point at 60. Our next data point is for March. For March, Bakersville had 50 construction workers. Let's go to March, travel up the y-axis until we reach 50, and plot a point. Our fourth data point is for April. Bakersville had 30 construction workers. Let's go to April, travel up the graph, and plot a point at 30. And last, for May, Bakersville had 50 employees. Let's go to May, travel up the graph, and plot a point. We have now plotted both lines on the graph, and we can answer the question. Let's continue. Austin is an astronomer, and he records data relating to Mars. The table below shows the number of asteroid impacts that hit the Martian moons Phobos and Deimos during different months. Use the data in the table to complete the double line graph. Like all of the other questions, we have one set of data already plotted for Phobos, and we need to plot our second series for Deimos. We're going to start with January. The number of asteroid impacts on Deimos in January is 90. We'll go to January, travel up until we reach 90 on the y-axis, and plot a point. For February, there were 30 asteroid impacts on Deimos. Let's go to February, travel up the y-axis until we reach 30, and plot a point. For March, Deimos had 60 asteroid impacts. Let's go to March on the x-axis, travel up the y-axis, and plot a point at 60. For April, Deimos had 80 asteroid impacts. We go to April, travel up the y-axis to 80, and plot a point. Next, we have May. And this is our last point. In May, Deimos again had 30. So we go to May, we travel up the y-axis until we reach 30, and we plot a point. We have now plotted all values for both Phobos and Deimos on the graph. So let's answer the question. Next question. Startup Edmonton's building temperature fluctuates wildly. The table below shows the temperature of Workspace 1 and Workspace 2 during different months. Use the data in the table to complete the double line graph. Workspace 1 has already been plotted on the graph. Workspace 2 has not. We need to go and look at all of the data points and plot them on the graph. Let's start with January. In January, Workspace 2 had an average temperature of 80 degrees Fahrenheit. In January, we will travel up the y-axis all the way up until 80 and plot a point. Next, we have February. In February, Workspace 2 had an average temperature of 90 degrees Fahrenheit. Let's go to February on the x-axis and travel up the y-axis until we reach 90 and plot a point. In March, Workspace 2 had an average temperature of 20 degrees Fahrenheit. That's pretty cold to be working. Let's plot that point. March, we're going to travel up until we reach 20 degrees Fahrenheit. In April, the Workspace 2 was a chilly 10 degrees Fahrenheit. Let's go ahead and plot that point on the axis. We go to April and we travel up the y-axis until we reach 10 and we plot a point. And the final temperature in May was 30 degrees Fahrenheit in Workspace 2. Let's go to May. We'll travel up the y-axis until we reach 30 degrees Fahrenheit and plot a point. Now let's answer the question. Oh, it looks like we got a duplicate. Same question again, but with some different temperatures. Startup Edmonton's building temperature fluctuates wildly. The table below shows the temperature of workspace 1 and workspace 2 during different months. Use the data in the table to complete the double line graph. Same situation, but different data this time. Let's look at the temperatures and begin plotting the data. In January, workspace 2 had a temperature of 70 degrees Fahrenheit. We go to January on the x-axis and we travel up the y-axis until we reach 70 degrees, and we plot a point. In February, the average workspace temperature in workspace 2 was 100 degrees. That's awfully hot. Hopefully they had some fans in their workspace. So we'll go to February on the x-axis and we'll travel all the way up until we reach 100 degrees Fahrenheit, and we'll plot a point. In March, the average temperature in workspace 2 was 90 degrees. We go to March on the x-axis, we travel up until we reach 90 degrees, and we plot a point. In April, the temperature in workspace 2 was 60 degrees. We go to April, we travel up the y-axis and we mark a point at 60 degrees. If we hover over the point, we can verify we have placed it at the correct location if we're unsure. And the last point is for May. We go to May and we travel up to 20 degrees and we plot our final point and we answer the question. All right, question number 7. The table below shows the consumption of 2 different sauces during various months. Use the data in the table to complete the double line graph. So we have pizza sauce and burrito sauce, and this is the amount of consumption. So first, we'll look at the burrito sauce since that has not been plotted on the graph yet. We see that the pizza sauce has already been plotted, and there's our data. Let's work with the burrito sauce. We'll start with January. In January, 40 units of burrito sauce was consumed. Let's go to January and travel up the line graph on the y-axis until we reach 40 and plot a point. In February, it was 100 units of burrito sauce consumed. Let's go to February and go all the way up until we reach 100 and plot a point. In March, 10 units of burrito sauce. We'll go to March, up the y-axis until we reach 10 and plot a point. The 2 line graphs actually intersect here, which means in March, both had the same value. Both burrito sauce and pizza sauce had 10 units consumed. Let's look at April. In April, 40 units of burrito sauce. Let's go up the y-axis and plot a point. This month also had the same amount. So the 2 line graphs intersect because pizza sauce and burrito sauce was consumed in the same amount this month. And lastly, in May, we have 70 units of burrito sauce. Let's go to May, travel up the y-axis until we reach 70, and plot a point. We have answered the question. Let's look at another question about 2 different sauces. This is the same information in the previous question, but with different data points. So let's plot the new data points. The table below shows the consumption of 2 different sauces during various months. Use the data in the table to complete the double line graph. Again, our first set of data, the pizza sauce, has already been graphed for us. We need to graph burrito sauce consumption so that we can see the 2 together on the graph. Let's look at January. In January, 10 units of burrito sauce were consumed. We go to January on the x-axis and we travel up until we reach 10 and we plot a point. The 2 graphs intersect here because the values are the same. In January, the same amount of both sauces was consumed. Let's look at February. Again, same amount of sauces consumed. We're going to plot the burrito sauce, 50 units. We go to February and we travel all the way up until 50. Let's go to the next data point. In March, only 10 units of burrito sauce was consumed. Let's go to March and travel up the y-axis until we reach 10 and plot a point. Next, April. In April, 30 units of burrito sauce was consumed. So let's go to April and we'll travel up the y-axis until we reach 30 and plot a point. The last data point for May is 40 units of burrito sauce. Let's go to May and travel up the line graph until we reach 40 on the y-axis and plot a point. We've now plotted both graphs and we can answer the question. Next question. The table below shows the number of nonfiction and fiction books that were checked out of the public library during different months. Use the data in the table to complete the double line graph below. The nonfiction data has already been graphed for us, but we do need to graph the fiction data. So let's start with January. In January, 30 fiction books were checked out of the public library. Let's go to January, travel up the graph on the y-axis until we reach 30, and plot a point. In February, also 30 fiction books were checked out of the library. We'll go to February, and we'll travel up the line graph and plot a point at 30. You can see that the line here is flat. That's because there was no change in the number of fiction books checked out between January and February. It stayed the same. Looking at March, 80 fiction books were checked out of the library. Let's go to March, travel up the graph until we reach 80 on the y-axis and plot a point. In April, only 10 fiction books were checked out of the library. When we go to April on the x-axis, we travel up to 10 and plot a point. And lastly, in May, 70 fiction books were checked out of the library. We go to May, we travel up to 70, and we plot a point. We've now graphed both graphs, and we can check our answer. This is our last question on this topic. Ultra Robotics makes robotic prosthetics to restore people's mobility. They produce robotic legs and arms based on demand. Use the data in the table to complete the double line graph. In the chart, we have the number of arms produced and the number of legs produced. The arm data has already been plotted on the graph for us. We're going to focus on the second set of data, the legs. In January, we travel across and we see that 50 prosthetic legs were produced. Let's go to January on the x-axis, travel up the y-axis until we reach 50, and plot a point. In February, 100 prosthetic legs were produced. We're going to go to February and travel all the way up until we reach 100 on the y-axis and plot a point. In March, again, 100 prosthetic legs were produced. Let's go to March, travel all the way up the graph, and plot another point at 100. In April, 80 prosthetic legs were produced. Go to April, we travel up the y-axis until we reach 80, and we plot a point. And lastly, in May, 50 legs were produced. We go to May, we travel up to 50, and we plot a point. We have now graphed both questions, both sets of data on the graph. Let's answer the last question. And that is how we create double line graphs using tables.